Hey everyone, this is Darshan Senthil, and in this video we're going to be talking about vectors. So before we go any further, let's just talk about what vectors are. So what are vectors? So vectors are quantities that have both a magnitude and a direction. In other words, it's a quantity that both has a bunch of stuff and is going somewhere. So some examples of vector quantities are force, acceleration, and velocity. So you will see this stuff in physics, but it's also important to math as well. So what actually defines a vector is that, like for example, let me just give you an example here. So if a force is going this way, it would be really different from a force that's going this way, right? This force pushes it that way, and that force pushes whatever it is this way. So they're pretty different. On the other hand, if you had a mass of like 5 kg, it doesn't really matter which way you're going or anything. It doesn't really have any direction to it. It's just 5 kilograms, period. But a force, on the other hand, is like, for example, 5 newtons in that direction, or 6 newtons in that direction. So that's basically what defines a vector. Okay. Oops. So vectors on a coordinate plane. So what does that mean? A coordinate plane, for vectors on a coordinate plane, just basically refers to vectors on graph. So basic vectors on a coordinate plane are always written in the following formula: x, y. In other words, it's how far you go horizontally and then how far you go vertically. It's like a coordinate, but make sure you pay attention for the square brackets that are pretty important. And this form is also known as component form. And this can also be written as like V. This could be any letter over there, but you just have to have that sort of thing up there. So you may see like this or whatever, like different ways. You could also see it as a bolded letter, but for obvious reasons I can't do a bolded letter here. So yeah, so always written as if it starts from 0, 0. So if you ever have a component vector, it's always written as if it starts at the origin 0, 0, and then goes up and goes right and up some quantity. Okay, so just keep that in mind. So let's just start off with a little example problem here. So for example, graph the vector 3, 4. So this is not too hard. We're just gonna go 3 units to the right, 3 units to the right, and 4 units up. So 1, 2, 3, 4. It's just about over there. Then draw a line connecting it. Because vectors have directions, it's not just a coordinate. You have to actually have a line over there. Okay, and so that's basically how you would graph a vector. But now what if we had to find the magnitude of that vector, or the size of the vector? And that would be a little bit more complicated, but it's not that hard. So if you actually look at this, you can solve for, so you know how far to the right it's gone. So you know it's gone 3 units to the right, and you know it's gone 4 units up. So now you can just use Pythagorean theorem and solve for this side. So the magnitude of the vector would be 4 squared plus 3 squared, which is 16 plus 9, which is square root of 25. Should probably draw these, which is just going to be 5. So the magnitude of this vector is 5 units. Okay, let's get rid of all that. So let's try another example right up here. So let's say that we're trying to find the component form of vector with the origin at 2, 1 and 3, 5. So now what we're trying to do is, we've not been given the vector from the origin. We've been given a vector starting from this point right here. So that's represented by this green arrow here. So what we need to do is we need to find what this vector would look like if it started from the origin. And how would we do that? Well, it's pretty simple. We're just gonna subtract the coordinates from each other. So we're gonna go 3, 5 minus 2, 1. So final coordinate minus initial coordinate. So that will give us 4 and 3. Sorry, oh my bad. That'll be 1. So 1, 4. And make sure you don't forget your square parentheses right there. So this would be the component form of your vector. I'm just going to write that out here. 1, 4. So what would this mean? So basically, if the same vector was moved right there, this is what it would look like. It would go 1 unit to the right and 4 units up. That's all you're determining from this. Right? On to the next thing. So adding or subtracting vectors is, again, no big deal. It's just basically, it's really simple actually. So adding and subtracting vectors, to do this you just need to line up the vectors and then add or subtract the x values and the y values. Okay, so basically you would just line up the vectors like say 6, 2 and 4, 3. Then you'd add the x's and you'd add the y's. That's it. Okay, so let's just do a couple of examples here. So this is kind of what you will see in a typical math problem. You'll see they'll give you a vector and then they'll define it as some letter. They'll define two vectors as letters and then they're just gonna go and say find these. So for here v is defined as 3, 2 and u is defined as 1, 2. So we're just gonna have to add v plus u. So this is really basic math. So 3, 2 plus 1, 2, just put them together, 4, 4. So that's v plus u. Now what about v minus u? So again, same thing, just minus. It's gonna be 0 and that's gonna be 2. And this is not hard stuff. Now the last one, just a little bit, you have to take one extra step here. So this is 2v plus 3u. So basically what you need to do is you need to multiply all this by 2 and then multiply all this by 3 and then add them. So it just look a little bit different. So you start off with the usual ones. The only difference is you would have an extra coefficient out here. So 2 over there and 3 over there. Okay. So then you would distribute the 2 over there and over there. You distribute the 3 over here and over here. And then this would ultimately become 2 times 3 is 6. 2 times 2 is 4. 3 times 1 is 3. 3 times 2 is 6. Make sure your brackets are squarey again. Sorry, I mean are triangulary again. And then you just add them as normal. So this would be 9, 10. And that is your answer. So that's it for this video. I'll have another video coming up shortly.